So we were talking about mandatory access control and MLS in particular, and the notion of trusted subjects. So the idea of trust is generally that trusted entities are exempted from policies, right? So this is sort of so the notion trust in security has this meaning that what you trust, then that means you're not enforcing any security policies. And of course, this seems like a bad idea because in real world, trust is rarely 0 or 1. So what you want instead is to be able to have some granular notion of trust. So in contemporary operating systems, trust is closely related to root processes, right? So because root processes are not, there is no security policy enforced on root processes, and therefore you are basically trusting root processes. The goal here with these alternative approaches is to come up with ways to limit this trust, right? So even trusted processes, you're going to enforce some policies so that if there were to be vulnerabilities in these trusted processes, the damage that can result due to those vulnerabilities is going to be limited. So we will talk in particular about domain and type enforcement, and then Linux capabilities. Okay, so what is domain and type enforcement? So the idea here is that you're going to take subjects, right? So you could have, let's say, the login. Okay. So maybe you have a login process, and that's going to be in a category, and then maybe bash is going to be in a category. Maybe there is your password program which you use for changing passwords. That could be a different category, and so on, right? And these categories are called domains, okay? And the idea is that you're going to group processes into domains so that policies can be enforced on them that that can be applied to all the processes or all the subjects in that domain. So for instance, login may be permitted to do certain things such as changing, starting out with root user ID and then changing its user ID to that of any normal user. Password is a program which you want to give it permission so that it can change the password and shadow files, but it shouldn't otherwise be able to change arbitrary files in the system. And bash, being a shell, may be given some set of permissions. So the idea is that instead of just saying that all of these are root processes and they can do anything on the system, you're going to really limit the particular accesses that each of those processes is able to do. And in order to express exactly what these processes can do, you're going to also, you're going to express your policies in terms of objects. And again, objects are going to be grouped into types, right? So maybe you would say that every file in /etc, this could be one category. Maybe you call them, say, config, right? And then you might say all the files in /bin is one category, and maybe you might call them, let's say, system programs, right? And then you might say, the user directory, right, could be, all those files could be in another category. And then you might say that, normal users can change files in this user category, but maybe they can't change files in other category, right? So the idea is that you're going to basically allow policies to be specialized for specific subjects instead of the default model where the user ID associated with the subject determines all the access, right? So in addition here, we are saying that the access permission is going to be determined both as a function of the subject and the object involved. So DTE is the mechanism that is implemented in SE Linux. So it's the core of SE Linux, which stands for Security Enhanced Linux, right? So this is a project that came out of the National Security Agency, NSA, and it's been the code for SE Linux has been integrated into the Linux kernel for the past close to 20 years, right? So it's there, and if you use the Red Hat Linux distribution, then the SE Linux features are more visible. But if you use Debian or Ubuntu, right? So we tend to use Ubuntu, and in Ubuntu, this SE Linux is the code is definitely there, but it is not enabled, and so you don't see it that much. So SE Linux, in fact, has in addition to the domain and type enforcement mechanism, it also incorporates the MLS that we talked about. But by and large, MLS is not enabled or configured, and so unless you specifically enable it and configure it, it's not something that you're going to see in a typical Red Hat distribution. So how does this deal with this trust problem? In the MLS, we needed to say, okay, there are these trusted programs which can arbitrarily violate the security policy, whereas here what we are saying is that there is no such thing as fully trusted program. The degree of trust you have is expressed by the domain to which the subject belongs. So if it belongs to the login domain, I'm going to give it certain permissions. If it belongs to the password domain, then I'm going to give it a different set of privileges and so on. And again, these domains are whatever you configure it to be, right? So this is the security administrator is going to design, define what these domains are and what subjects belong to what domains, and from there the policies are going to be applied based on the subject's domain. So once again, even though this is a very good idea in principle to limit the privilege of and not have unbounded trust, in practice, its use is also has been quite difficult to use, because in practice, DTE has turned out to be sort of one policy per application, right? So although you can categorize them and put them into domains, very often what ends up happening is that you to get any level of security, you have to essentially define a policy for each application, and defining these policies is quite difficult. And if you get the policy wrong, then what happens is that that application breaks at runtime. So essentially, it experiences a security failure, and then it's going to basically crash. And so, it's really difficult to get the policy right, and therefore, to configure DTE and get it to work on contemporary operating systems is quite difficult. And this has, partly this is responsible for why Ubuntu is more popular than say Red Hat, because Red Hat has this DTE mechanism more fully deployed, and therefore it's going to be a little bit harder to use because things can break. On the other hand, in Ubuntu, it doesn't use these policies that much, and so it's easier. So applications less frequently encounter security failures. So again, there is always this conflict between security and functionality that we face, and it has to be one has to. The trick is to develop security mechanisms that are relatively easy to use, so usability doesn't suffer too much. But unfortunately, DTE is not one of those mechanisms, and it is quite difficult to use. And so in practice, the Linux community has instead gone for something else called Linux capabilities, which is something that we will talk about next.